In Iowa, the poor water quality is common knowledge, but what is in the water that makes it low quality and what is being done about it is not. Chris Jones explains what exactly is in the water and his role as a research engineer at the University of Iowa.
The main function of my job is to manage the university's network of water quality sensors that are deployed across Iowa, mainly in streams at about 60 sites. We use that data to conduct water quality research on the condition of Iowa streams. The sensors test for nitrate, pH, dissolved oxygen, conductivity, temperature, and turbidity. Stream nitrate is probably our most talked about water quality problem, probably our most difficult one to solve. We do have some lakes where nitrate is a problem. The nitrate levels in the river are probably somewhat stable to maybe slightly increasing. 29% of the nitrate in the Gulf of Mexico is from Iowa. And then about half of that comes from four rivers, and that would be the Cedar, the Iowa, the Des Moines, and the Raccoon. The Raccoon River that we have here has probably got the highest nitrate concentration of any stream in North America. So the drinking water in Iowa City has improved a lot over the last 15 years because they built a new treatment plant. The water treatment plant on Dubuque Street is a modern lime softening water treatment plant that does a great job of treating the water. The drinking water here is far better than it was 20 years ago.
Explaining how Iowa City's water is treated and the process that gets water from the ground to your faucet is Iowa City Water's senior operator, Craig Meacham.
Our primary source is our collector wells in the alluvial aquifer, which are in contact with the surface water, and it is replenished by the river. The aquifer acts as a natural filter, so our raw water is really high quality, low in organics and low in turbidity. And then we bring the water in, it goes through an aerator, which removes some carbon dioxide and ammonia, and it can oxidize out iron if necessary. And that helps our lime dose. And then we go into a process called lime softening, which removes about 2/3 of calcium hardness in the water, and that makes for a better product. And then we do our corrosion control, so we make our water slightly scaling, so it protects the water from the pipes, and that's how we do our lead and copper program. It protect the customers from lead and copper corrosion. Then it goes to our granular activated carbon filters, which the GAC removes organics and also does some mechanical filtration to get any particles that may be left in the water. And then we do disinfection, where we add chlorine gas to disinfect the water, and we have some chlorine contact tanks that allow for mixing and detention time to allow the disinfection process to complete. And then we have a couple of ground storage reservoirs here at the plant to keep our supply up. And the ground storage reservoir goes into a clear well that we pump out of and with our high pressure pumps to the city. We have a lot of little emergencies, but our goals are to stay out of the news. So, we have various feed systems that break down and main breaks that occur, and as long as our customers open their tap and get water, we're good. But no one ever knows that kind of stuff goes on, and that's the way it should be.